Okay, today in 4.4 we're going to make some connections with a few of the things that we've been studying. So the I can statement for today is I can understand the connection between rates of change and slope. So we've talked about both of those things. We found rates of change and we found slope, and now we're going to talk about how we can connect the two of these ideas. They're very, very closely related. So in the warm-up, it says rate of change is a fraction that shows how much the quantities have blank from one measurement to the next. So remember, when we do rate of change, we're comparing measurements from one measurement to the next, and we're checking to see how much the quantities have changed from that one measurement to the next measurement. And then there's a formula for rate of change, and it's always the change in the second quantity. I know that sometimes seems a little bit backwards, but we put the change in the second quantity on the top, and we put the change in the first quantity on the bottom. Now, it's really important to be able to calculate rates of change, because that leads us to something that's extremely important when we're looking at graphs on the XY plane. Now, there are lots of graphs that can be drawn on the XY plane, all sorts of them, all sorts of different shapes and things like that. But one of the simplest and the most common is the graph of a line. We study lines quite a bit to start off because they're fairly simple and easy to work with. A lot of cool properties though. Now, even though a line is a really simple shape and stuff like that, there are a lot of important features that make lines different from each other. So let's write the word different. So you'd think, well, a line is a line, but it's not. There are a lot of different features that can make them different from one another. And one of the most important features is how steep the line is. Okay, so we're going to write the word steep right there. Now, if we look at these graphs down below, you'll notice that there are some similarities and there are some differences. Okay, so take a look at those right now and notice that some of the things are the same and some things are different there. One thing that's different about the lines is two of them go up from left to right. Okay, these two, as we're going from left to right, which we typically do, start with the negatives and go toward the positives. So this one goes up from left to right, and this one goes up from left to right. And these other two lines go down from left to right. So down from left to right. So as we're going from the negative x's to the positive x's, we start up here and we go down, and we start up here and we go down. So these go up from left to right, these two go down from left to right. Okay, and each of them, if you take a good look, each of them also has kind of a different steepness. So this is kind of shallow, this is kind of steep, this is steep in the other direction, and this is really steep in the other direction. And remember, the word that we're going to use for steepness, we're going to start using slope. We're going to use that word all the time. Now, we're at the point where we can actually give a pretty good definition that tells us exactly what slope is. So I'm going to put an asterisk by this, and I'd like you to do the same thing. So let's fill in the blanks here. Slope is a fraction. I'd like you to always think of slope as a fraction. Sometimes it will be written as a whole number, but I want you to always think of it as a fraction. And if it's not written as a fraction, think about how you could write it as a fraction. So slope is a fraction that describes how steep a line is. There's that word again. So slope is a fraction that describes how steep a line is and in which direction it slants. Okay, so you go ahead and get that written down. I'm going to say the whole thing again because this is going to be used over and over again. So you should be able to tell somebody what slope is, and here's a pretty good description. Slope is a fraction that describes how steep a line is and in which direction it slants. It does two things. It tells us how steep it is, okay, how steep it's slanted or how shallow it is, and it also tells us which direction it slants. Does it go up from left to right, or does it go down from left to right? Okay. So let's take a look at this next part right here, and we're going to try and make this as easy as we possibly can. So it's easy to make the slope of a fraction if we're given the graph of a line by keeping in mind the formula for rate of change and the fact that y is the second coordinate and x is the first coordinate. So if we think of the rate of change formula, the rate of change formula is going to be the difference in the second quantity divided by the difference in the first quantity. Well, y is the second coordinate or the second quantity. So slope is going to be the change in the y's over the change in the x's. Now you'll notice that this is the same as when we were talking about the change in the vertical over the change in the horizontal that we were talking about in the last couple of sections. So we're always going to put the vertical change, that up and down portion, okay, whether we go up and down, and we're going to put that over the horizontal change, whether we go to the right or the left. Okay, so we've talked about that for a while, and now we're going to make it even easier. So since the x-axis runs right and left, and the y-axis is up and down, we're going to give these directions special names, make it a little bit easier so we don't have to say vertical and horizontal all the time. So the change in y, we're going to call that the rise. So the rise is going to be the change in y, and the change in x is going to be called the run. All right, and we also use a special letter for slope. We use the letter M, and we'll talk a little bit more about that later. But we're going to talk about slope in terms of the letter M. So if anybody uses the letter M from now on, they're usually talking about the slope of a line. And we're going to say this: since the change in y is the rise, that's going to go on the top. So we're going to say the slope is the rise over the change in x, and that's going to be the run. So two R words, kind of a little alliteration there. So we need to know what slope is. Slope is a fraction that describes how steep a line is and in which direction it slants. And a quick little formula for slope is it's the rise, this is whether we go up or down, okay, over the run, whether we go right or left. So slope is rise over run. So keep that in mind. There are a couple things that we've got to make sure that we have memorized. This is going to come up over and over and over again, so make sure you've got that down. So let's flip the page over and let's take a look at a couple of examples. Okay, very similar to ones that you're going to do on your assignment. So it says find the slope of each line by drawing a right triangle using the line as a hypotenuse. So remember, we did this before, so hopefully this rings a bell. And it has a little reminder here. It says remember to start at the leftmost point and go up or down first. Find the rise first, and then always make sure that you reduce the slope fraction. So I'm going to underline and, so we want to remember a couple things. When we draw this triangle, now you'll notice that these are two really convenient points. This one is right at the origin, and this is right where a dot would be, so it's going to be pretty easy to count. And again, it would be better if we figured out whether we went up or down first, figure out the rise first, and then the run. That's going to be much, much better in the long run. So let's take a look at this and let's count how far we went up. So the rise is 1. Remember, we're counting spaces, not little marks. So 1, 2, 3, 4. So I'm going to write rise equals 4. Now we went up, so that's going to be a positive 4. And then the run is going to be, this would be 1, 2, 3 spaces. So the run on this one would be positive 3. So remember, the slope formula is, flip over to that other side, rise over run. So we're going to do the rise is 4 and the run is 3. That can't be reduced at all, so this right here is the answer. So we'll just circle that and we're all finished. It's literally that easy. So let's do the next one. Now on this one, remember, we've got this nice convenient point here and we've got this nice convenient point here. We want to make sure that we find the rise first. Again, you don't have to, but it's going to make things better in the long run if you do. So from this point to this point, let's go up or down to get there. So I'm going to have to go down. I'm going to have to go down all the way that far, and then we're going to run over that far. And again, if you'll find this rise first, that's going to make things much better. Now let's count spaces here. So this is 1, 2, 3, 4, 5. So the rise is 5. Now, we actually went down. So remember, we're getting a little bit more sophisticated here. The slope fraction is going to tell us how steep it is and which direction it slants. So going up 4 is not the same as going down 4, and going down 5 is not the same as going up 5. So we're going to write this down as a negative 5. So to go from here to here, the first thing we're going to do is we're going to go down 5, and then we're going to go to the right. Let's see, let's count 1, 2, 3, 4, 5. So the run on this one is 5. So the rise is negative 5. That indicates we go down. Remember, the slope's got to tell us which direction it slants. So the slope is going to be the rise, negative 5, over the run, which is positive 5. So the answer on this one is negative 1. Okay, there's the slope. Now, I'm going to point this out right now, and then we're going to talk about it a little bit more in just a few minutes. So the slope of this one right here on A is 4/3. That's a positive 4/3. Okay, the slope of this one, now the first one, A, is a little bit steeper than this one, but this one definitely goes in the other direction. And you can notice that there's definitely something that's different about the two of these. This one's positive and this one's negative. So we've got a slope of negative 1 for B. We've got a slope of 4/3 for this one right here. And then let's take a look at C. This one's kind of interesting. We're going to go from this point to this point. Now, we could draw a triangle on A and B on these examples here, but you can't draw a triangle on this one. To get from the left point to the right point, all we can do is go from here to here. So, is there a rise? Do we go up or down to get from this point on the left to this point on the right? Well, we don't. The rise would be 0. Okay, and then let's count what the run would be. The run would be how far we go from left to right. Remember, rise is up and down. We didn't go up or down at all. Run is how far we go left to right. So let's count. This would be 1, 2, 3, 4, 5, 6, 7. So the run is 7. So the slope is the rise over the run. So we're going to put 0 on the top and 7 on the bottom. Remember, we can take 0 and divide it by a number. We just can't divide by 0. So this is totally okay. If you want to throw that in your calculator, it will tell you that the answer on this one is 0. Okay, so we've got our answer on that one. And then we've got this last example right here. So this looks a little bit weird, but let's check and see. It's kind of the opposite of this case right here. So we're going to go from this one to this one. Now, to go from here, we can go down. So this is going to be a rise. So the rise on this one would be, let's see, we go down 1, 2, 3, 4, 5, 6. So the fact that we went down, we're going to represent that with a -6. And then the run on this one, since we didn't go right or left at all, the run is going to be 0. So the rise is -6. The run is 0. Now remember, you can't divide by 0, so we get no slope. We don't get an answer for that. There are some people that also say that that's undefined, but either way is totally fine with me. I like both ways of describing that, whether it's no slope or the slope is undefined. Now, that's our first chance at talking about exactly what slope is. So we want to make sure that we're clear on how we can remember this, because we're going to practice this a whole bunch. We're going to use slope all the time. It's going to be in every class you take from now on. So let's make sure we're clear here. So here's a way to remember that. Horizontal, this is horizontal, it's flat like the horizon, have a slope of 0, and this is called vertical, and vertical lines have no slope. So vertical lines have no slope. So this is horizontal right here. This is vertical right here. So horizontal, this has a slope of 0. Vertical, this has no slope. So a way that you can remember this is when we think of the word slope, we often think of a mountain slope. In fact, that may be why they called it or used an M to represent the slope. In fact, some of the best guesses are that it comes from a French word montir, which stands for mountain. Okay, so since the slope is a number that measures how steep the line is, imagine if we were dropped off with a helicopter and we were going mountain skiing or snowboarding or something like that. So we're going to go heli-skiing, and we've got a helicopter hovering up here, and it's going to drop us off on one of these slopes right here. So we've got 4 choices right here. Okay, now as you get dropped off, I want you to think to yourself this question: is there a number that represents how steep this slope is? Well, if there's something for you to land on, then there is a fraction or a number that represents how steep that line is. Okay, so let's say the helicopter's buzzing around here and it drops us off and we land on this. Okay, so we're like this and we start heading this way right here. Okay, then this slope, there's something for us to land on. This slope has been designated as positive. Okay, because as we're going from left to right, we're going up. Okay. Now, on this one right here, if we got dropped off from the helicopter's hovering around here, we jump out, and here's what happens on this one. We just kind of sit there. It's totally flat. Okay, so because there's something for us to land on, then there's a number that represents how steep that is, and that slope fraction happens to be 0. Let's do this next one. So if we get dropped off, the helicopter's hovering here. Okay, we land on this. Okay, and there we are. There is something for us to land on, so we can start skiing or snowboarding or whatever. Okay, so that slope, if this one's positive going up from left to right, then this one's going to be negative. Okay, so there's something for us to land on, so there's a number that represents that. That slope would be positive. There's something for us to land on. We wouldn't slide either direction, so that slope happens to be 0. And then this would be, there's something for us to land on here, and it happens to go down from left to right, so we call that a negative slope. Now, imagine if we were hovering over here. If we were hovering over here and the helicopter dropped us off, think about what's going to happen here. We are just going to continue going down. There is no slope for us to land on. Okay, there's no number that represents how steep that line is. Okay, so I'm hoping that helps you keep keep this straight. We are going to use this and talk about this over and over again, so if you've got a question, please make sure you ask. But let me just kind of summarize what's going on there, okay? Remember, if there's something for you to land on, so if you take your arm or draw a line or something like that, as long as you could get dropped off and there's something for you to land on, then there is a fraction that represents how steep it is. If the line goes up from left to right, then we say the slope is positive. If it's flat, we say the slope is 0. The number that represents that slope would be 0. We don't slide either direction. And if the line goes down from left to right, like this one does right here, then we say the slope is negative. Now, if there's nothing for us to land on, like this example right here, then there's no number that represents how steep that line is, so there is no slope. Now, again, as a reminder, some people say that the slope of a vertical line, remember this is vertical, okay, in fact I'm going to write that down right there, that's vertical and this is horizontal. We're going to talk more about that coming up, I think, later in this chapter in the next one. So this is a horizontal line and that's a vertical line. So some people say that the slope of a vertical line is undefined. So just realize if they say it's undefined, what they mean is there's no number to represent how steep that is. That's the same thing as saying no slope. So no slope and undefined mean exactly the same thing. You'll hear both terms used interchangeably. And what they mean is there's no number to represent how steep the line is. So we're going to summarize all of this. Now, we've been talking about slope for this entire time. So again, this is a summary here. Slope is a fraction. I always want you to think of slope as a fraction. Slope is a fraction that describes how steep the line is and in which direction it slants. Okay, the size of the fraction, so the bigger the number, that tells you how steep it is. So the bigger the fraction, the steeper the line is. And the sign, whether it's positive or negative, that represents the direction that it slants. So positive slopes up from left to right and negative slopes down from left to right. So to make sure that we know how to do the problems on the assignment, we're going to take a look at problem number 9 and problem number 15. But again, keep this stuff in mind right here. Again, the definition of slope, and then you've also got to keep in mind that slope is going to be rise over run. Okay, really important that you have those memorized. So let's take a look at number 9 and number 15. Okay, so I've got the worksheet up here. Here's 4.4, slope from a graph. You'll notice that the points are already picked there. You can draw the triangles. We draw a triangle like this, and then a triangle like that, and so forth. You can do each one of those. And let's take a look at number 9 and number 15. Now, on the previous set of graphs, you'll notice that they gave you points. On number 9 through 16, there's a line, but there are no points on there. So we're going to choose what I like to call convenient points. Convenient points, let me give you an example. This one right here would not be a convenient point. Neither would that. But this one is a nice convenient point. That one's not, but this one is. You can pick any two convenient points you want and it'll give you the same answer. So let's take a look at number 9. I'm going to zoom in on this one so we can kind of see what's going on a little bit better. Those are two convenient points. And you might have in your mind to figure out what makes this a convenient point. These cross at nice points, so it's really easy to describe and count from one to the other. So again, we need to figure out the rise and the run. So the rise over the run, we're going to have that in our minds all the time. Please make sure you remember that. So we're going to go from here to here. So I'm going to go up, I'm going to rise, and then I'm going to run. So the rise on this one, rise is, let's see, 1, 2, 3. And the run is 1. So let's see, we've got a rise of 3, a run of 1, so the answer on this one is 3. So the slope on number 9 is 3. So you'll notice that this is a pretty steep line and it goes up from left to right. The fact that this is a positive 3 means it's going to go up from left to right, and the fact that it's the number 3 is a relatively large number. So it's going to be pretty steep in the positive direction. Now, I usually have somebody say, hey, could I do this different? Could I do something else? Could I pick some other points? Yes, you could. Okay, so let's say we erase the two of those and we do this. I'm going to pick that convenient point right there, and then I'm going to pick this convenient point down here. So we're going to rise from here to here and run from here to here. So again, I'm going to do the rise first, and then I'm going to do the run. So we're going to go up 1, 2, 3, 4, 5, 6. So the rise on this one is 6, and the run on this one, 1, 2. So the run on this one is 2. So the rise is 6, and the run is 2. So we end up with 6 over 2, which is 3. So we get the same answer there. I will often have somebody say, hey, could I do this? Could I go the other direction? We could go down and then over. You've just got to make sure you keep these straight. So this would be a rise. Let's go from left to right. So we're going to go over. So that's going to be a run of 2. You can count them off. And a rise of, let's see, 1, 2, 3, 4, 5, 6. Okay. So again, we'll get 6 over 2, which is 3 over 1, or positive 3. Now, the last thing I'm going to do is, so take a look at those answers and kind of convince yourself that those are right. I'm going to change colors, and I'm going to do exactly the same thing, except for I'm going to go the other direction. So I'm going to use those same points, because usually somebody says, hey, what if I went from here to there and I went down? Well, if I went down, then the rise would be negative 1, 2, 3. I went down 6, so that would be negative 6. So if I'm going the other direction, so if I'm going from right to left, I would go down 6, and then I'd have to go back 2. So think about this. If we go back 2, we're going to the left, so we've got to indicate that we're going backwards. So that would be a run of negative 2. Now take a look. The rise of negative 6, the run of negative 2. We end up with a positive 3 either way. So lots of different ways to do those problems. Please make sure you're careful. I kind of like being in the habit of always going from left to right. What that does is it makes sure that our run is always positive, and then we just have to figure out whether the rise is positive or negative. So keep that in mind, and then I'm going to slide down here and take a look at number 15. And we're going to do the same thing on this one. Now, some of these you've got to be really careful about the points you choose. So that one I see a little bit of a gap in there. So I'm going to say this is a convenient point. See how it's going a little bit below there and a little bit more? I'm going to go down here until I find one that looks just perfect. And I think that's it right there. Okay, that one doesn't look quite right to me. Looks like it's a little bit above that nice intersection right there. So we're going to go from left to right. So I'm going to go from this point down to here. We're going to make that slope triangle. So we're going to go down 1, 2, 3, 4, 5, 6. So that is a rise of negative 6. And that is a run 1, 2, 3, 4, 5. That's a run of 5. So if we do the rise over the run, and again I'm going to write this several times, rise over run, that would be negative 6 over 5. We can't reduce that. We do normally write the negative out in front, so I'm just going to go ahead and write it that way. Now, what I want you to keep in mind here is, remember, if it goes down from left to right, our answer needs to be negative. This one goes down from left to right. That's why it works out to be negative. So if you were to miss something and say you left that as a positive 6 and you did 6 over 5, you would know there's a problem in your work somewhere, because we should never get a positive answer for a line that slopes down from left to right. By the same token over here, we shouldn't get a negative answer for something that slopes up from left to right. And then let me point out one more thing. The number here is a 3, or a 3 over 1. That's pretty steep. And this one right here is 6/5. That's just a little bit over 1. So it's kind of steep in the negative direction, but not much. On this one right here, we'd be expecting a fairly small number because it's not very steep. And then again, keep in mind the two of these, because this one's horizontal and this one's vertical. Pick some points and figure out what the slopes are there. Now I'm going to do one last thing before we're done. I'm going to take a look at number 15 again, and I'm just going to show you that as long as you do this correctly, it should work out either way. So I'm going to go from this point to this point, but I'm going to go backwards. I'm going to start right here and I'm going to end up there. So I'm going to go up and I'm going to go back. So if I went up, I'd be 1, 2, 3, 4, 5, 6. That means the rise would be positive 6. Now the run, we're going left, we're going backwards, so we're going in a negative direction. So this would be 1, 2, 3, 4, 5. The run on this one would need to be negative 5. So take a look. If we do rise over run, rise would be 6, run would be negative 5. We end up with negative 6/5 either way. Okay, that's what the assignment is like. It's got these different types of problems. Again, we're finding slope from a graph. Think about that formula, rise over run. Think about what the definition of slope is and things like that. Really good stuff. Got to make sure you remember it.